In data science interviews, you'll often get this question: what's the difference between correlation and covariance in Python? It sounds simple, but it actually checks whether you really understand relationships between features, how scale affects them, and whether you can use that insight during feature engineering. Here's the quick way to remember it. You calculate correlation using Pandas' built-in correlation function and covariance using the covariance function. Now let's make sense of what they mean. Covariance tells you how two variables move together. If both increase or decrease in sync, it's positive. If one goes up while the other drops, it's negative. But covariance depends on scale. So if one variable is measured in thousands and another in tens, the result becomes difficult to interpret. Correlation fixes that problem. It's just a scaled version of covariance that normalizes the values between -1 and +1. This tells you both the direction and the strength of the relationship, instantly, and without worrying about units. In short, covariance gives direction, while correlation gives direction and strength. And that's what makes correlation the go-to choice when you're exploring data before modeling. Now, let's take it a level deeper with an example you can use in your interview. Covariance measures how two variables change together, but it's unbounded and depends on the scale of your data. That's why two features measured in different units can produce misleadingly large or small numbers. Correlation, on the other hand, standardizes that measure. It divides covariance by the product of standard deviations, bringing everything onto a clean scale between -1 and +1. So, a value close to 1 means a strong positive link, close to -1 means a strong negative link, and around 0 means there's no linear connection. Here's how you do it in Python. You'd start by importing Pandas and Seaborn. Then, select your numeric columns, say feature 1, feature 2, and your target variable, and call the correlation function to calculate the matrix. Finally, visualize it with a Seaborn heatmap, which highlights how each feature relates to every other one. Now, let's bring this to a real-world case. Imagine an e-commerce platform finds a correlation of 0.87 between email open rates and purchase conversions. That means the more people open marketing emails, the higher the chances they'll buy. This insight helped the business fine-tune its campaign targeting, leading to over £2 million in additional revenue. So, if this comes up in your interview, here's a confident and complete answer you can use. Covariance tells me how two features move together, while correlation is a normalized version that shows both direction and strength. I usually calculate it using Pandas' correlation function and visualize it with a Seaborn heatmap to spot strong relationships quickly. That's the kind of clear, applied answer that tells your interviewer you don't just know the concept, you know how to use it in real analysis.